Okay, now to the Lhopital's rule problems that I had sent you on an email. If you've not seen that email, please open it up and work through these problems before watching my video. First one is the limit as x approaches 0 of the sine inverse of x over 2x. Well, the sine inverse of 0, okay, you think about what angle gives you a sine of 0, and that would be 0. 0 is the angle that has a sine of 0. Sine of 0 is 0. So this is 0, and in the denominator, we get 0, so that is called the indeterminate form. So because it's the indeterminate form, we're allowed to use Lhopital's rule to figure out what the derivative is. To figure out what the limit is. Well, the derivative of sine inverse of x and I'm going to put therefore use Lhopital's rule. So the limit as x approaches 0 of, all right, the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. And the derivative of 2x, this is the tough one. That's right, it's 2. So now we start plugging in 0, so it becomes 1 over the square root of 1 over 2. So we just get 1/2. So the limit as x approaches 0 of sine inverse of x over 2x is 1/2. All right, so let's look at this next one. We want to determine the indeterminate form here. So we get, all right, it's the square root of 7 minus 3 plus 7 minus 9 over 49 minus 49. Okay, so we get 0 in the denominator. But looking at the numerator is the square root of 7 minus 5. So we get the square root of 7 minus 5 all over 0, and that's not an indeterminate form. And this is not defined, so this limit does not exist. Not an indeterminate form. You cannot do Lhopital's rule if you don't have an indeterminate form. That's the reason it's important to see what the form is first. All right, on to the next problem. Okay, we plug in 0, so we get the square root of, okay, this is 0. Cosine of 0 is 1, so it's the square root of 1. Well, guess what? We're not going to have an indeterminate form here either. So let's see what happens. It's not automatically, does not exist though. So we get 0. This is 2 times 1, or 2 times 0, which is 0. 0 plus 1. So it's the square root of 1 over the square root of 1, which is just 1. So this one did not have an indeterminate form, and it actually had a limit. On to the next problem. Okay, so it's e and natural log, two of our favorite things. E to the 1 minus 1 is e to the 0, which is 1. So we get 1 minus 1 over the natural log of 1. Remember, the graph of the natural log does this. It crosses 0 at 1. So it's 0. So we get 0 over 0. So we are going to use Lhopital's rule. Okay, so the derivative of e to the x minus 1 is e to the x minus 1, and then the derivative of x minus 1 is 1, so it's times 1. Of course, you wouldn't have to put that in there. And then the derivative of the natural log of x is 1 over x. So we get e to the 0 over 1. So it's 1 over 1, which is 1. So that's Lhopital's rule, and it worked. Okay, now, the next one, we didn't really deal with any of these in the past. And let's say, okay, I don't know what cotangent of 0 is, but I do know that cotangent is cosine of x over sine of x. Well, this would be 0 times 1 over 0, so we get 0 over 0. So again, I'm going to use Lhopital's rule. Now, another thing you could have done here is you could have said, well, I know that this is 0. Now, the cotangent of 0 is undefined. It's cotangent, again, I don't want to get this wrong, but it's got an asymptote there. It doesn't say we're approaching 0 from the left or 0 from the right, so it just does not exist. So 0 times infinity, for lack of a better thing right there. So this was an indeterminate form, and anyway, it yields this. So let's go with this form right here, because this is in the form of a quotient, so the derivative of the numerator. Now, derivative of the numerator means that we're going to have to use the product rule. So it's the limit as x approaches 0 of, all right, this is going to be x squared times negative sine of x plus 2x times cosine of x, and that's all over the derivative of sine of x is negative cosine of, no, it's positive cosine of x. All right, so we start plugging in 0, so we get 0 plus 0 over the cosine of 0, which is 1, so we get 0 over 1, which is just 0. So there we end up with the solution of 0 for the limit there. So again, you would probably want to put, oh, I did write it, use Lhopital's rule there. You want to include that each time. Again, I have no idea if they're going to use this or not. I lean toward thinking that they would put Lhopital's rule on it in another video, but after watching the webinar I watched last night, I don't know. I don't know how that would be tested, but the more practice we get on it, the better. Hopefully that went well for you. Remember, do not take the derivatives until you know it's in the indeterminate form. That's going to be the key thing here, because if you took the derivatives before you put it in indeterminate, before you determined it was an indeterminate form and then plugged in the limit, you might get a wrong answer. Lhopital's rule is only guaranteed to work if you are in the indeterminate form. Okay, I will be sending out a little bit later I'll go ahead and give you the next problem of the day. Next problem of the day, let's just go on to 2019 free response number 6. I have not looked at it yet. I don't know what that problem is going to entail, so we'll see. Hope everything goes well. Bye.